Well, hello geometers and seekers of general truths. In this video, will figure out the exact values of the cosine of 45 degrees and the sine of 45 degrees. I want to stress here that we're figuring out the exact values, and we're going to do it in simplest radical form. In the previous examples, you see that we do a lot of rounding and we do a lot of estimation, and even your calculator or computers, when they calculate the cosine and sine of angles, all they're doing is an estimation. But we can actually reason our way through. That's what geometry and mathematics is about, is reasoning in some cases through an exact answer. So let's get right to it. The cosine of 45 degrees and the sine of 45 degrees. And whenever you see cosine, sine, tangent of 45 degrees, we're dealing with a special right triangle. So we're going to be working with the special theorems, or the theorems of special right triangles. In this case, with 45 degrees, we're going to use the 45-45-90 triangle theorem. Namely that the hypotenuse is the square root of 2 times as long as each leg. So when I draw this up, I'm going to have a 45 degree angle here and a 45 degree angle here. And because those two angles are congruent, these two legs are also congruent. And I don't know the length of any of these, so I'll just call this one x. And because this leg is congruent to this one, we can also call that x. And the hypotenuse, we'll call it y for right now. Okay. So the cosine of 45 is equal to the ratio of the leg, and we'll use this angle here as our reference. The leg adjacent, right? So toa, the leg adjacent, which is x, divided by the hypotenuse, which is y. Now that doesn't seem to get us anywhere until we apply this theorem. The hypotenuse is square root of 2 times each leg. So that tells us then that the hypotenuse, y, is equal to the square root of 2 times the leg, which is x. So now we can expand this fraction. We have x in the numerator, and instead of y, we get square root of 2x. Okay. Then our x variables cancel. In the numerator, we are going to end up with 1, and in the denominator, we're going to end up with the square root of 2. Now we want to make that in simplest radical form, so we're going to multiply by a special version of the number 1, multiply by root 2 over root 2. Our final answer, we have the square root of 2 in the numerator and just 2 in the denominator. So from this we can say that the cosine of a 45 degree angle is always equal to the square root of 2 divided by 2. This is the exact and most precise representation of the cosine of 45. Now let's do the same thing for the sine of 45. We're using this as our reference angle. The opposite leg in this case is x, and the adjacent leg in this case, the hypotenuse, excuse me, so sine is opposite over hypotenuse is y. And you can see here that the sine of 45 is the exact same thing as the cosine of 45. We don't need to repeat all this extra work because we've done it already. So this is all going to turn out to be the square root of 2 over 2. Okay. And the reason for this is that if you have a 45 degree angle, you have an isosceles right triangle. So the adjacent leg and the opposite leg of a 45 degree angle will always be the same. So there we have it, two calculations of the sine of 45 and the cosine of 45. And I want to emphasize that we are able to come up with this answer in exact values in simplest radical form. All right, I'm going to end this video here, and we are going to work on another one that focuses on the other special angles, the 30 degree and the 60 degree angles.